In 3.6, we are looking at optimization problems. All right, what that means is we're kind of putting the stuff we learned in the first part of this chapter into action, into some word problems. We're trying to either minimize or maximize some value. And we're going to do that using some of the stuff that we've learned in this chapter. So our goal is to minimize or maximize. So just some guidelines for this. And first few are kind of the same guidelines you would use for just about any word problem. One, read the problem carefully, probably more than once. Sketch a picture or diagram if appropriate. Sometimes you might have one drawn for you already. Then step 3 is to write down any information given from the problem and any other information that relates to the problem, like a formula. So those 3 are kind of standard for any type of a word problem that you're doing. The fourth one asks us to determine which variable is to be maximized or minimized. Like I said, one or the other is going to happen. We're either minimizing or maximizing. And we have to express this variable as a function of one of the other variables. All right. So when we write an equation, it has to be in terms of one other variable. We can't have like 2 other variables on the right side of the equation. It has to be just one. After we've figured out that equation, maybe simplified it if we need to, we're going to start using our calculus. We're going to find the critical values, right? Because to find maximums and minimums helps us to find the critical values, because that's where local maxes and local mins tend to occur. And then the last part is determine the extrema, like the absolute min or absolute max, using a first derivative number line or a second derivative test. And we want to remember to check the endpoints whenever appropriate.